Hi there, and welcome to my presentation on the superposition theorem. The superposition theorem is a circuit analysis technique that allows for the calculation of unknown voltages and currents in a circuit with multiple power sources. You can achieve this by analyzing the circuit through the lens of each power source acting independently. The algebraic sum of these individual currents or voltages can represent the true measurement in the original circuit. The methodology of the superposition theorem relies on the usage of other, more simpler techniques in its analysis process. Firstly, select a power source as your reference, then suppress the other inputs accordingly. Analyze the circuit using just the identified source, and then repeat for all of the sources in the circuit. Once completed, sum the measurements together to find the total desired measurement. So what exactly do I mean when I say suppress the other power sources? In the context of a circuit diagram, this will involve replacing voltage sources with a short circuit and current sources with an open circuit as represented in the figure. Note that no current can flow through an open circuit branch. So let's look at an application of the theorem. Say you want to calculate the current flowing through R2 while it is simultaneously affected by both the 6 amp current source and the 10 volt voltage source. We must first analyze the circuit through each source independently. So I've selected to isolate the voltage source first, but ultimately it doesn't really matter which one you choose initially. In doing so, the current source has been replaced by an open circuit, thus no current will flow in that branch. The resultant circuit is a simple series circuit with two resistors experiencing the same current. We can now utilize Ohm's law to determine the current through both resistors as approximately 0.125 amps. Now we can isolate the current source. In turn, we have short-circuited the voltage source to create a configuration of two resistors in parallel. We can now utilize the current divider rule to determine the current flowing through R2 to be approximately 3.75 amps. Now that both sources have been analyzed independently of each other, the algebraic sum of the currents in each configuration can be added together to find the total current flowing through R2 in the original circuit, which totals approximately 3.875 amps. However, it is important to note that the previous application of the theorem can only be applied given certain conditions are met. Firstly, the circuit must contain only linear elements, which are effectively components that have a linearly proportional relationship between voltage and current. Note that this is able to include ideal capacitors and inductors as well as resistors. Additionally, power cannot be calculated in parts like voltage and current can, and must be instead calculated once the overall measurement has been found. Lastly, the polarities of voltages and current directions must remain consistent across the entire analysis. For example, if current directions that oppose each other in different configurations, they would need to be subtracted from each other rather than added. Thank you for watching.